Well, we spent a unit now learning about things like rise over run, slopes, lines, x-intercepts, y-intercepts, and all this sort of stuff. You may ask yourself, why do we need to know this sort of stuff? Why is it useful in the real world? And this is where word problems can help us get a little idea of how we might apply some of this theoretical stuff into real world scenarios. So let's look at the example of a business, running a business. Aaron owns a television repair company. He charges $30 for making a house repair call, plus $25 per hour in labor. Graph the linear relation. The table of values shows his fee schedule, where C represents the total labor cost, and N represents the number of hours of labor. So in these sort of situations, you'll often see this word here, $25 per hour. And when you see words like this, per hour, or he makes $50 an hour, or he's traveling 30 kilometers per hour, these kind of words give an indication or a little hint that we're talking about the slope. In this case here, 25, as we're going to find out soon, is indeed the slope. And just when you read this phrases like this, it'll give a little hint as to what the slope might be. So here we have a situation where the x-axis represents the number of hours, and the y-axis represents the cost that Aaron will charge for repairing whatever appliance he happens to be repairing. So we can see that at 0 hours, the cost is $30. And this is because Aaron charges an initial cost of $30 just for showing up. So even before any job has been done, any work or any labor has been performed at all, he will be charging $30 just for showing up at your door. So we've already talked a little bit about the slope, this word per hour. Okay. So our slope, as we know, is rise over run. In this example, we're talking about amount per hour, which could also be written as amount over an hour, and it's 25. Now, we know this for a few reasons. One way we can know that the slope is 25, or the rate of change is 25, is to look at the table of values. And as you see, we've got the x values, or the n values as we're called in this particular example, are in sequence. So we can look at the y values and see what the difference is as we move from one y value to the next. And the difference happens to be 25. We could also see it graphically. Right here, we're at the point 0, 30. And if we go over 1 hour, we'll see that we have a rise of 25. When we take this y value or cost of $30 and we rise to 55. So that's just another way. So now we have a few different ways of figuring out what the slope is. Now, the fixed cost is the point or the amount that's being charged at 0 hours. So as we've learned before, the value of y when x equals 0 is our y-intercept, or in this case, the value of amount when n equals 0 is 30. So we have enough information already to know that m is 25 and our y-intercept is 30. So with that amount of information, we can write our equation, y equals 25x plus 30, or probably more specific to this particular question, we could say that y, or the amount, equals 25n plus 30. So what is the slope in this relationship? We've already figured that out. It's 25. And what does the slope represent in this problem? Well, it's the amount extra that's charged after every hour, or it's the amount charged per hour. So as we see on the animation, as we move over 1 hour, the amount increases by 25. Question E asks, what is the y-intercept of this relationship? Well, the y-intercept is the value of y when x, or in this case n, equals 0. And what does the y-intercept represent in this problem? Well, it represents the amount of money that's charged for a house call even before any labor is performed. By looking at the graph, how much would it cost to repair our television if the work took 5 hours? Well, we could simply take our graph, move across to the 5-hour mark, and then move up, and we'd see that the cost was $155. Question H, by looking at the graph, how many hours of labor would be required to repair a television if it cost $230? Well, in this case, we can simply look at the 230 amount mark, move over to the graph, and then move directly vertically down until we reach the number of hours. And we'd see that it would take 8 hours to cost $230. For the printing of a bound report, the Done Quick Printing Company charges customers $100 for printing setup costs and $5 per copy. Graph the linear relationship. The table of values shows that the fee schedule, where C represents the total cost of printing and N represents the number of copies of a report printed. So we can see that right at the 0-hour mark here, and from the table of values, that the cost is already $100. And we can see that for every, for every copy, well, we could work this out by using rise over run. We'll see that the run here is 10, and the rise is 50. The rise is the difference between 150 and 100, as we'll see in a second. So what is the slope of this relationship? Before that, we can see that each copy, and these are the copies right here, 5, 10, 15, 20, for each additional copy that's printed, the cost goes up by $5. So we can say that the cost is $5 per copy, which tells us that the slope is 5. And what does the slope represent in this problem? Well, it represents the cost per copy. Seem to have written the amount that is charged per hour, but that's not quite right. It's the amount that is charged per copy. What is the y-intercept of this relationship? Well, the y-intercept is the y value when x, or in this case n, is 0. And then we can see that it is 100. So the y-intercept is 100. And what does the y-intercept represent in this problem? It represents the setup costs. Even before any copies are made, a certain amount of work has to be done preparing the setup, and this cost is $100. And then after that, there's an additional $5 per copy. By looking at the graph, how much would it cost to print 40 copies of a report? Well, we can simply look at our graph here, come across to the 40 copies point, and then go up vertically, and we'd see that that matches the 300 on the cost or y-axis. So it would cost $300 to copy 40 copies, and for 60 we would do the same. We'd come across to the 60 copy mark and then move up vertically until we hit the graph, and we see that it hits the graph right at the $400 mark, so it would cost $400 to print 60 copies. By looking on the graph, how many copies of the report were printed if it cost $225. Well, now we're given the cost and asked to measure what the number of copies is. So we just do this backwards. We move up until we get to $225, which is right here. Then we move across until we get to the graph, and we see that that intersects right at the point 25, 225. So we could say that it would cost $225 to print 25 copies. Then we're told that the cost is $550. So in this case, we would just move up until we got to the 550 mark, which is right here, move across until we reach the graph, and we would see that that intersection is 9550. So we could say that if it was going to cost $550, that would mean that 90 copies were being printed.